between while loop and do while loop. Comparison between while and do while. While, do while. Okay. So while loop means it is also called as pre-tested iteration statement. And do while post-tested. So while is pre-tested iteration statement and do while is post-tested iteration statement. So in definition, we will write first while loop is also called as pre-tested. This is post-tested. So one comparison or difference. Next, second one. Condition is tested at the beginning. And here condition tested at the end. So condition tested at the beginning and condition tested at the end in do while. Here in condition tested at the beginning. Okay, because it is pre-tested and it is post-tested. Now statement not executed. Statement not executed even at once means first it checks the condition, then it executes the statement. But here the statement executed at once means before checking the condition only the statement executed. But here after checking the condition only the statement is executed. Means here if the condition is true then set of statement is executed. Means if it is true then only the condition statement will be executed. Then when it becomes false then control comes out of the structure. But here even if it is if the condition is false at the beginning itself, one statement is executed. Okay. Then one syntax. Write the syntax. While condition set of statements. Set of statements. Here syntax do open bracket set of statements close the bracket while condition semicolon. Okay, here condition should be terminated because at the end the condition will be checked. Here at the beginning, so no termination from the condition. Okay, only in case of do while the condition will be terminated. Remember. So set of statements or statement 1, statement 2 and statement n also you can write. Okay. Next one example. Fifth one example. Easily you can write the differences or comparison between while and do while in case if they ask for 5 marks. Now I'll take sum of the numbers, that is 1 to 10. Okay, 1 to 10 natural numbers. I is equal to 1. Next while I less than is equal to 10. Open bracket. Sum is equal to sum plus I is equal to I plus 1. It's a simple example. Same example you can take for the do while also. Do, so before that initialize sum is equal to 0. I is equal to 1. Next do, open bracket, sum is equal to sum plus I is equal to I plus 1, close the bracket, then while I less than is equal to 10. Okay, to find the sum of 1 to 10 numbers. Sum is equal to 0, I is equal to 1. In case of while condition, next sum is equal to sum plus I is equal to I plus 1. In case of do while, sum is equal to 0, same thing, whatever written in while, but here do should be written first. Okay, before opening the flower bracket, you have to write the do, then sum is equal to sum plus I is equal to I plus 1 semicolon, close the flower bracket, while I less than is equal to 10. Same example, how to write using do while. Okay, so this is about comparison between while and do while. In case if they ask 5 mark question, other differences or comparisons also there, but it is the simplest. In case if they ask for 3 marks, 1, 2, 3 you can write. Okay, otherwise if they ask 5 mark, then 5 comparisons or differences. What is the difference between or comparison between while and do while? While is pre-tested iteration statement, do while is post-tested iteration statement. Next, second one, condition tested at the beginning in case of while, condition tested at the end in case of do while. Next, statement not executed even at once. Means if the condition is true, then set of statement is executed. But here, even if the condition is false at the beginning itself, statement executed at least once. At least once you write. At least once. Okay? Once the statement is executed. Okay? Next, while condition set of statements, do while, that is set of statement, while condition should be terminated. Sum is equal to 0, I is equal to 1. That is an example to find sum of 1 to 10 numbers. Okay, this is about comparison. Okay, so now you know the difference between while and do while. Same way you can compare for also. Okay. Now, next move on to for loop. For loop. Now what is for loop? loop. It is also called as fixed execution iteration or looping. Execution, looping. Looping and iteration one and the same. It is also called as fixed execution looping statement. Then what is for loop? When it is used, when the user knows exactly how many times the set of statements are executed repeatedly again and again, then we use for loop. So for loop is also called as fixed execution iteration statement. Why? Because if the user knows exactly how many times the set of statements are executed repeatedly again and again until the condition is satisfied. Okay, so for loop, use of for loop. Okay, so that it is also called as how many times exactly the set of statement executed. If the user knows how many times exactly the set of statements are to be executed, so that it is called fixed execution iteration or looping statement. Okay, now what is the syntax? For expression 1, expression 2, expression 3. Next, open curly bracket, set of statements. Or you can write statement 1, statement 2, n statement. Anyway, you can write set of statement means n number of statements. Okay. So here expression 1 indicates initialization. Expression 2 indicates final condition or value. Expression 3 indicates incrementation or decrementation. So, expression 1 indicates initialization. Here also for initialization, semicolon, final condition or final value, semicolon, incrementation or decrementation, close the bracket. Like that also you can write. Okay. But here I have used expression 1, semicolon, expression 2, semicolon, expression 3. That means expression 1 indicates initialization, means here you have to write initialized value, and here you have to write final condition or final value, and expression 3 indicates incrementation or decrementation. Okay, this is the syntax. Now what is the flow chart for the same? Hexagon symbol for expression 1, semicolon, expression 2, semicolon, expression 3. Close the bracket. Set of statements. Next, control variable, that should be connected here. Control from here to here. So for expression 1, expression 2, expression 3, final value to the incrementation and decrementation. Control should be connected to here. Control variable. In program, whatever variable used by you. For example, normally we use I. If you use J loop, J should be connected here. Here you have to take J. That is the control variable. Okay. So that should be connected here, and you have to use dotted line, not straight line. While doing programming constructs, once I told, only in case of for you have to use control variables. Okay, so dotted lines you have to use, not straight line, remember. Okay, so for loop, expression 1, expression 2, expression 3, set of statements within flower bracket, and if there is single statement, directly you can write without using flower brackets. Next, expression 1 indicates initialization, expression 2 indicates final condition or final value, and expression 3 indicates incrementation or decrementation. In case they ask, explain for loop statement with the programming example. With an example, then just write part of the program, means whatever logic written, whatever logic given, that you have to write. Means in programming construct, I have given the part of the program, that is logic part. Here they ask, from this chapter they ask with the programming example. So you have to write one programming example, one small example I will give, then I move on to the practical programs. Okay. Write a C++ program to display or print odd numbers. Up to given limit. The way we give the limit, we have to mention it n limit. So that three library functions hash include IOStream.h, hash include conio.h, hash include iomanic.h. Three header files. Normally we use three header files. Void main, open flower bracket. So this is the structure. Next, int. I take n and I for loop. So here using loop, no for loop, no. So that n is the number, then I is the incrementation. For loop we use I. So n. TSP, Cout, enter the limit. See here given up to given limit. Enter the limit. Sin n. Now here I is equal to 1. In loop we have to mention I is equal to 1. Before that the odd numbers are, or we know odd number only going to print, so that without heading also you can write, because this is a simple programming example. So that for directly I write after the input for loop, for I is equal to 1, starting from 1, I less than is equal to n, I is equal to I plus 2. I is equal equal to I plus 2. Starting from 1. First it prints 1. Next the condition whether it is less than or equal to n. I is equal to I plus 2. First time it prints 1. Then it prints 3. I is equal to 1. No. First it prints 1. Next I plus 2. 3. 3 plus 2. 5. 5 plus 2. 7. 9 and so on. Okay. Next, C out, set with I. Get C and close the flag. Okay. So here I is equal to 1. First it prints 1. Next iteration. This checks whether I less than is equal to n. If it is yes, so stops printing. If it is no, stops printing. If it is yes, then I less than is equal to n. Then if it is true, it prints. If it is false, means if it is greater than n, then it stops printing. For example, enter the limit. If I give 10, this is the output. If I give 10, after running the program, it asks you to enter the limit. Saying n, I have given 10. Then the output will be, first it prints 1, next 3, next 5, next 7, next 9. 10 is not odd number. Okay? Because after 9, it becomes 11. 11 is greater than n. The condition not true, then it stops printing. If it is 15, then 11, 13, 15. Because I less than is equal to n. Till 15 it checks. Clear? Okay. So this is the simple program to display odd numbers up to given limit. Okay. So in case if they ask explain for loop with the programming example, this program you write. This is the simplest program. Okay. Now next one more practical program. Write a C++ program to generate Fibonacci up to the limit, means up to the given limit. This is the practical program. This program not included in the theory, purely practical program, but algorithm and flowchart is included in the theory. That is programming construct that is using while loop. While doing programming constructs, we have written the algorithm and flowchart for the same, but using while loop, but here using for loop. So we have to write program, algorithm and flowchart. Okay. So first write hash include pre-header files. iostream.h hash include io conio.h or io manage.h hash include io manage.h. bracket. Now we have to declare the variables. And I'll take n, that is number to input, then a, b value, c value. Along with that, we are using for loop here. In programming construct, you have used counter variable ct while writing algorithm and flowchart. But here we are using for loop. Normally in for loop we use I loop, j loop, like that way. So that I will take I variable, then it becomes easier for you while writing the for loop. So n is the number, a, b, c. You have to initialize a value and b value, and you have to find the c value. Okay. Next, clear screen. See out. Enter the limit. Or you can write number also, but in question they have given limit, so that enter the limit. Seal. Yeah. Next, a is equal to 0, b is equal to 1. A is equal to 0, b is equal to 1. Next, see out. The Fibonacci numbers are A, second, and B. Okay. So the Fibonacci numbers are, first time it prints A's value 0, B's value 1. Now we have to write the loop for I is equal to 2. Next number I already declared here, so that no need of using int here. Okay, in case if you didn't declare I variable, and while writing for loop you have to mention int I, but here already declared. So I is equal to 2, I less than n, I plus plus. Okay. Next, open bracket. How to find the third value? C is equal to A plus B, because Fibonacci means sum of previous numbers. Okay, sum of previous numbers. A's value already assigned 0 and 1. 0 is A and B is equal to 1. Okay, so 0 plus 1, C will get, that is the third number. Next, see out, set with C. Means, see here A, set with B, next set with C, means to get the multiple spaces. Next, A is equal to B, B is equal to C, close the flat bracket. So it repeats until the condition is satisfied. Okay. So first it prints A and B, that is whatever value assigned. Then it checks the loop. I is equal to 2. First starting from 0, 1, 2. Next number is third number. This is the third number. Here we have taken 0, 1. Value also 0, 1 and started from 0. So NRA anyhow subscript of NRA starts from 0, no? So same way here also 0, 1, 2, third number. You get third number. C is equal to variable used to get the third value is A and C. So C is equal to A plus B. Whatever sum you got, that will be assigned to here. Then it prints the next number. Okay. Then A is equal to B. Already in the place of C some value is there. That should be swapped. Okay, how to swap? A is equal to B, B is equal to C, and close the flat bracket. It repeats until the condition is satisfied. When it is greater than n, it stops checking, then control comes out of the structure. Okay, gets yet, close the flat bracket. Clear? So this is the program to generate n Fibonacci on series up to limit using for loop. So n is a number, a, b, c, that is a is equal to 0, b is equal to 1. First two values, then this is to get the third value. Next, I for the loop. Okay, so clear screen. See out, enter the limit. If you enter the limit, for example, you write the output. Here I write. Enter the limit. If you give 5, the Fibonacci numbers are age value 0. Next set weight, namespace 1. Next third value c is equal to a plus b means 0 plus 1 1. That is set weight, space given. Next a is equal to b, then c is equal to b. Then again you can calculate c. See next number. Then 1 plus 1, 2. Next 2 plus 1, 3. So if you give the limit 5, then 5 values printed on the screen. Okay. This is the practical program, not the theory program. That means for theory, this program is not, we will not ask this program. For theory, only for practical. But flowchart and algorithm, that is in the theory, so that will be asked. Not the program. This is purely practical program. This and that one more program. If else if that switch program, that is to input the marks and find the result. Class to class that finished. That and this program purely practical programs. Then no need to study for the theory purpose, but practical study. Okay, but from this, whatever flowchart and algorithm given in programming construct, that is required for the theory exams. Okay, so practical exam, this one. For theory exam, no need to read this program. Only for the purpose of practical. Because theory, this program is not included. Clear? Okay. Now next, we have to write the flowchart and algorithm for the same, because here we have used for loop while doing the programming construct. There we have used while. If you want, check once. Okay. Now write the algorithm for the same. Step. What is an algorithm? Step by step procedure to solve a problem, given problem. Step 1, start. Step 2, input n. Step 3, initialization, that is a is equal to 0, comma, b is equal to 1. Next, step 4, for I is equal to 2, I less than n, I plus plus. If you want, you can open star bracket, otherwise at the end of for loop you have to write. So without opening star bracket, program that star brackets are must. C is equal to a plus b, output, here also you have to write the output. Output after the A and B, I is equal to 2, I less than n, I plus plus. Next, C is equal to A plus B, output to C. Next, A is equal to B, B is equal to C. Now write end of for loop. Next is step 6, stop. If you use flat bracket, open flat bracket, here you have to close after B is equal to C. Otherwise, without opening, this indicates what? This is the opening of for loop, then end of for loop. Step 1 start, step 2 input n based on the program. We have declared variables there, but we are only to declare the variables, all the variables. Just write what is the input given by you. Next, initialization if any. So in that program, in this program, A is equal to 0, B is equal to 1. Next output you will get A and B. Next loop, C there. Next C is equal to A plus B, output C. There you have opened flat bracket because that is the program. Program algorithm is not same as program. It is near to the program like pseudocode. Okay. So here we use end of for loop, but there you have to use the specific structure only, that is opening flat bracket and closing flat bracket. If you write end of for loop there, then you get error. So that there you have to follow the rules. Here either you can use flat brackets, here open, here close. Otherwise, after this end of for loop. Next, step 6 stop. This is the logic. Okay, now draw the flow chart. Start, input n, next A, B, next for loop. Now, C is equal to A plus B. Next, output C. Next, A is equal to B. Next line or same line, B is equal to C. Next, you have to connect. I connector, okay. It repeats until the condition is true. When it becomes false, that is after I, you have to give stop. So here, after I, this stop. Okay. So start, input n. A is equal to 0, B is equal to 1 initialization. If so, the output A comma B, then loop, then next one C is equal to A plus B, then output C, then A is equal to B, B is equal to C. that is for swapping. Next, you have to connect the control variable here. See here, the variable taken by you is I, so I connector that connects to here. This way or this way. Anyway, you can write. Then see, after I put arrow mark, I have written stop here. Don't write it separately. They only connect. Okay. Here there is no space, so that I have written here. Otherwise, again I have to redraw the flowchart. That is one of the disadvantages of flowchart. Okay. So stop. After the I connector, down arrow mark, right stop. Okay. Clear? Hope you understood. So this is the algorithm. That is the flow chart to generate Fibonacci series up to the limit using formula. Practical program. So that algorithm and flow chart must. Already you have written flow chart and algorithm for the same, but it is using while loop, but here for. Okay. Hope you understood. Okay. Next, move on to the next practical program. Write a C++ program to find the factorial of given number. For this already flowchart and algorithm finished using for loop only. Here we need to write the program, only the program. So write down the algorithm and flowcharts. Okay, this is using for loop. Whatever written, that is by using while loop. Hash include IO stream.h hash include for IO.h hash include IO man.h hash include while main open flag bracket. So 3 header files and while main open flag bracket. Here we need to find the factorial of a given number, so that we have to declare n, then get the factorial fact and one for loop, so that I int n is the number, then I for loop, then I take fact. Okay. Next PSP. Next cout. Enter the number. Seal n. Next, fact is equal to 1. Fact is equal to 1. Next loop for I is equal to 1, I less than is equal to n, I plus plus. So starting from 1 till where I less than is equal to n. When it becomes greater than n, then it stops checking, then it prints the output. Then I plus plus incrementation. First it is 1, next iteration 2, next 3, next 4, next 5 n numbers. If your input is 5, then till 5. I less than is equal to n means till 5 then stops checking and print the output. Next, fact is equal to fact into I. Fact is equal to fact into I. Next, see out the factorial is where it is stored in the variable fact. See here, fact is equal to fact into I. Next, get CH, close the flower bracket. Get CH, close the flower bracket. So how the output will be? So output is equal to enter the number. If I use 5, then the factorial is we get the answer 120. So this is the output. Okay. So how? See here, first time fact is equal to fact we have initialized to 1. That is first time 1. I is equal to 1. Right. So that fact is equal to 1 into 1. So 1 only. Next time I is incremented by 1. See here, I plus plus. I becomes 2. Now 1 into 2. So 2. Now fact is 2 here. I plus 1. So first time I is equal to 1. Next time it is 2. 2 plus 1. Now I value 3. Fact is equal to fact value. See this is 2. I value incremented by 1. That is 3. 2 into 3 6. Now fact is 6. I incremented by 1. That is 4. So 6 into 4 24. Now fact is equal to 24 plus 1. I is incremented by 1. 6 in 5. So that into 5. So how much? 120. So 120 will be printed on the screen as an output. The factorial of a number is 120. So 3 header files, then while main, open bracket, 8 n I fact. N is to input the number or value, I for loop, fact, that is to find the factorial. Enter the number C in n. Next, fact is equal to 1, semicolon. Next, for I is equal to 1, I less than n, I plus plus. Fact is equal to fact into I. Next, the output will be printed. Get CH, close the flower bracket. Okay. So this is about factorial of a given number. This is a practical program. Okay, now if you want to compare with the compare for loop with the while and do while. Anyhow, you know the comparison between while and do while. While is pre-tested iteration structure for a statement. Do while is post-tested iteration statement or looping statement, and for loop is fixed iteration execution statement. You can write. Okay. Then here in while loop condition will be checked at the end. Do while condition will be checked at the end. But here when the user knows exactly how many times the set of statements are executed again and again until the condition is satisfied. Then syntax of while is while condition, open flower bracket, statements, close the flower brackets. Do while, do, open flower bracket, set of statements, close the flower bracket, and while condition followed by semicolon. And in for loop, for expression 1 that is initialization, then final value expression 2, then expression 3 incrementation and decrementation, then the set of statements within flower bracket. Next, this one example. So to find the numbers, find the sum of 1 to 10 numbers. First your initialize sum is equal to 0, I is equal to 1, while open flower bracket I less than is equal to 10. Next I is equal to I plus 1. Next number, sorry, sum is equal to sum, I less than is equal to n. Open flower bracket, you have to make the sum is equal to sum plus I. Next you have to write the incrementation, I is equal to I plus 1. Semicolon, close the flower bracket. That is in while loop. Do while loop, do, next open flower bracket. Before that sum is equal to 0, I is equal to 1. Now initialize, do open flower bracket, sum is equal to sum plus I is equal to I plus 1. Close the flower bracket. While loop, while I less than is equal to 10, then condition should be terminated. In case of for, sum you have to initialize, sum is equal to 0. I no need to initialize because in loop only I'll initialize. First expression is that is initialization. So that sum is equal to 0. For I is equal to 1, I less than is equal to n, I plus plus. Next to open flower bracket, sum is equal to sum plus I, close the flower bracket, semicolon, close the flower bracket. With the flower bracket or without flower bracket also works because there is only one statement. Then no need of writing I is equal to I plus 1 because first statement is I is equal to 1. Then last expression is, first expression is I is equal to 1, last expression is I plus plus, incrementation. There